All right. Good morning. Today, unfortunately, I can't be there, so I'm making this video for you. Today what we're going to do is we're going to finish lesson 3.3, which was all about completing the square. Now, hopefully you guys remember a little bit about what completing the square means, but if you don't worry, because I'm going to help you. So let's start by recapping what it means to complete the square. We had to first notice what is the pattern between the factored form of quadratic expressions being squared and the standard form of the quadratic expressions. So hopefully you remember that there's this trick we can use, which is whatever the a value is, whatever this a value is, I know I'm just going to multiply it by 2 to get the b value and square it to get the c value, right? So next one would be x squared plus 4x plus 4 because 2 times 2 is 4 and 2 squared is also 4. Looking at the next one, if I do x plus 3 squared, that's x squared plus 6x plus 9 because 3 times 2 is 6 and 3 squared is 9. And this pattern is going to work for all of them. And that's how you end up doing them a lot quicker when you recognize that pattern. And then we took that information and we wrote it in a more formal rule, which is that the b value is equal to 2 times a, and the c value is equal to a squared. That was the main takeaway from this exercise. Then we thought about, okay, if I know how to go from factored to standard form, could I use this relationship to figure out how to go backwards, to go from standard form to factored form? And the answer is yes. To find out what the a value is, I basically just do the inverse of each of these operations. So if I want the a value, I'm just going to divide b by 2. Or I could take the c value, whatever that is, and square root it. But both of these have to be true. Both of these have to equal the same value a in order for it to be factored correctly, right? So this first one would be x plus 6 squared, then x minus 6 squared, then x plus 10 squared, then x minus 3/2 squared, then x plus 50 squared. And then we get to the last one and we recognize that there's a problem. b divided by 2 does not give us the same value as the square root of 3. So 8 divided by 2 does not equal the same thing as the c value, the square root of the c value. So here we have a problem. These are all called perfect square trinomials because they could be factored in such a way that their factors are the same, that they give us a quantity squared or a binomial squared. But this last one is not considered a perfect square trinomial because that's not the case. And it's not the case because these two quantities are not equivalent. They don't equal each other. But in math, that doesn't stop us, okay? Just because it's not what we want originally doesn't mean we could be creative with it, doesn't mean we could be smart about it and kind of work the system a little bit, kind of try to work around it. So what we realized is even though this isn't a perfect square trinomial, I could still force it to be a perfect square trinomial, while at the same time ensuring that whatever I do, I could still prove that it's equivalent to this original expression. So if I could do things as I wanted, instead of a 3, I would want a 16. So why don't I just add a 16 to this? And then we talked about how if you add 16 to this expression, it's no longer equivalent to the previous expression. So that's not mathematically correct. How I could fix that, though, is if I add 16, I could also subtract 16. So essentially, all I'm doing here is adding 0 to my expression. And that doesn't change anything. If you add 0 to anything, nothing changes. So that is mathematically correct and mathematically equivalent to what we had before. Why did I do that? Because now these first 3 terms here make a perfect square trinomial that I could write in factored form. And then I can just simplify these pieces outside the parentheses, and I get negative 13. Now, if we go to Desmos real quick, if we graph this, if you remember, we proved that the graph of this function, x squared plus 8x plus 3, is in fact the same as this function, right? All I'm doing is adding 0. And it's also the same as this function. All three of these represent the same function. So I very intelligently, very creatively, kind of finagled the system a little bit, worked the system a little bit to get a perfect square trinomial, while at the same time keeping in mind that there's certain mathematical principles that I have to be aware of and apply, okay? Now the perk of completing the square, of getting a perfect square trinomial, is that now this expression is in vertex form. And that means I could easily identify the vertex to be -4 and -13, which I wasn't able to do with such ease with this original expression, okay? So anytime we complete the square, what we want is a perfect square trinomial. And when we do that, when we complete the square, we end up getting a vertex form quadratic, okay? So that's basically what we did last class. We looked at some examples. We talked about how if you don't know right away what value to add to the expression or the equation so that it is a perfect square trinomial, you could just use this formula here. Now let's take a second to recall where that comes from. If you remember, we had said that to find the a value, we would divide the b value by 2, and that the a value would also have to be equal to the c value, the square root of the c value. Both of these have to be true. So if I want to find the c value, what I could do is I could substitute this into the second equation so that I get b divided by 2 equals the square root of c. And now if I want to find c, if I want to find the perfect value to add to my equation or expression, I'm going to square both sides. And so c is equal to b divided by 2 squared. So that's where this formula comes from. Remember, there's always some sort of math. There's always some math that we have to do to get these formulas that we use. So we tried a problem with that in example 2. And if I remember correctly, we had left off with example 3. This problem we had not done yet. So what we want to do for example 3 is we want to solve this equation by completing the square. Remember, to complete the square means I want a perfect square trinomial. And if you look at the equation that we have, there is no perfect square trinomial there at the moment. But that's not going to stop us. We could still work through it. So I'm going to go ahead and just use the formula from above, the b divided by 2 squared, to figure out what value I should add and subtract to this equation. So it doesn't really matter that it's a negative or a positive 10, because regardless, when you square it, it's going to be positive. But let's keep it consistent and actually use the b value. So -2 divided by 10 is -5. -5 squared is 25. Now, sometimes you could just look at this expression or this equation and already know what the c value is, but this formula is good to use when it's not as clear. So what this means is I'm going to take my equation, x squared minus 10x, and I'm going to just add and subtract 25. All I'm doing is adding adding 0. But the perk is now I have a perfect square trinomial. So in factored form, that's x minus 5 squared. And then outside of the parentheses, I have -25 plus 7, which is just 18. Well, I should say -18 equals 0. So that is the equation after I've completed the square. And now that I have it in this form, I'm going to solve by using square roots, which means isolate the variable. And I think that's the easiest way to do this at the moment. So right now I'm going to go ahead and add 18 to both sides. I'm going to square root both sides. Remember that when you do that, you have to add a plus or minus to one side. I'm not going to leave the square root of 18 like that. I have to simplify it. So just remember that 18 could be broken up into 9 times 2, and the square root of 9 is 3. So that means we have x minus 5 equals plus or minus 3 root 2. And now I add 5 to both sides and get 5 plus or minus 3 root 2 as my final answer. Now, something I want to make clear. If you look at that original equation, it's not factorable. Okay, I can't factor that. So that means at the moment, the only option I have would be to graph it. But if you notice, the x values that we're getting are not nice numbers, which means if I was to graph this by hand, it'd be impossible for me to figure out that those are the x-intercepts without using an algebraic approach. If I had a graphing calculator, then I could figure out the x-intercepts, but otherwise completing the square is the only reasonable method that I could use here that would give me accurate x-intercepts, right? Accurate x values, x solutions to the equation without having to estimate or approximate, okay? And I know you're probably looking at those x-intercepts and saying, that's not what I got. But remember, the square root of 2 is like 1. I got to start remembering these. It's about 1.414. Let's see. So 5 plus 3 times the square root of 2 is 9.2426. 9.2426, which is the x-intercept that we got there. And then 5 minus 3 root 2 is going to give us the other one, okay? And just remember, the square root of 2 is, got it, 1.414. So 3 times that, 3 times that is 4.242. And then when you add or subtract by 5, or when you add 5 to that or subtract that from 5, you get those two x-intercepts, okay? Alrighty, so moving on. Example 4. We want to solve this equation by completing the square. Again, that means we want a perfect square trinomial. And hopefully you're looking at this and you're recognizing that this is kind of different from all the problems we've seen before, because every problem we've seen up to this point hasn't had a value for a other than 1, right? Here, the a value is 1. Here, the a value is 1, and so on. Now, that is important. In order to get a perfect square trinomial, we need the a value to be 1. So because this is an equation, we have two options. We could either factor out a 3 from this left side of the equation, or the easier option, because it's an equation, is we could just divide everything by 3. Now, I do want to make a point that if this wasn't an equation but was only a function or an expression, we could not divide both sides by 3. We would have to factor it out, okay? So if I divide everything by 3, what I get is x squared plus 4x plus 5 equals 0. Now, I still don't have a perfect square trinomial, but that's fine. What I need to do is find the c value that I would want to add and subtract to this. So that ends up being 4. And as you do these more, as you practice them more, you'll start to just realize immediately what the c value is, because things will start to look a little familiar. So here, there's my perfect square trinomial. So what I get is x plus 2 squared, and then negative 4 plus 5 is positive 1 on the outside. And now I'm going to solve this using square roots, isolating the variable. So subtract 1 on both sides, square root both sides, add the plus or minus. Now remember, the square root of negative 1 is, you got it, it's I. So we have plus or minus I. And then x equals negative 2 plus or minus I. That's our final answer. So again, this problem here, I couldn't have solved it by factoring. And if I graphed it, I wouldn't have obtained that answer, because if I graph it, there are no x-intercepts. So if I graph this 3x squared plus 12x plus 15, there are no x-intercepts. So I could have only found that answer by completing the square up to this point. And there is another method that I could use, but we haven't learned that yet, so I'm not going to talk about it. So this next piece of information, we've kind of already discussed, but I want to reiterate it. So remember that the vertex form of a quadratic function is given by y equals a times x minus h squared plus k, where h comma k is the vertex of the graph of the function. You can write a quadratic function in vertex form by completing the square. So if I look at this equation, this function, I don't have a perfect square trinomial, but I want one. So what do? I get the b value, I divide it by 2, and then I square it. So y equals x squared minus 12x. 12 divided by 2 is 6. 6 squared is 36. So I add and I subtract 36. Here is my perfect square trinomial. So that's x minus 6 squared. And then negative 36 plus 18 is negative 18. So that's my equation in vertex form. And the vertex here is 6 comma negative 18. Let's do this just to be a little bit extra. The axis of symmetry is x equals 6. What would the domain and range be? Maybe pause the video and try it. The domain is going to be all real numbers, right? The domain of any quadratic is all real numbers. The range, well, remember, the minimum or maximum is the y value. And in this case, because the parabola is opening up, since there's no reflection, what that means is that we have a minimum value at negative 18. So our range is going to begin at negative 18 and continue on to positive infinity. And then this function is going to be increasing. Remember, it's going to look something like this. This function is going to be increasing from the x value of the vertex to the right. So it's going to be increasing from 6 to infinity and then decreasing from negative infinity to 6. Okay, just trying to bring back some of that information that we've covered before in terms of quadratics. Very good. Andiamo, onward. Example 6. The height y in feet of a baseball t seconds after it is hit can be modeled by the function y equals negative 16t squared plus 96t plus 3. Find the max height of the baseball. How long does the ball take to hit the ground? All right. Well, if it's asking us to find the max height of the baseball, let's remember what that means. What they're asking us to find is the vertex of the function. Okay. Now, if I want to find the vertex of the function, and this is a standard form equation, remember I could do x equals negative b over 2a, and then whatever that value is, plug it back into the function. Now, that will work. However, right now in this lesson, we've been learning about rewriting standard form equations to vertex form equations. So why don't we try that? Even though these numbers are pretty big and it might not be that easy, let's do it. Let's challenge ourselves and do it. So if I wanted to get this into vertex form, remember the first obstacle, the first problem, is that this a value is not 1. Now remember I said that if I want to get rid of that a value and I'm dealing with an equation or a function, well, I shouldn't say equation, a function, I can't just divide everything by negative 16. What I have to do instead is I have to factor it out. So if I factor out a negative 16, what I'm left with in the parentheses is t squared. And then how many times does 16 go into 96? Let's find out. Oh, perfect. It goes into it evenly. It goes into it 6 times. So what that means is in the parentheses, I'll have minus 6t. And then 16 doesn't go into 3 evenly, but 3 doesn't even help me get a perfect square trinomial. So you know what I'm going to do? I'm just going to exclude 3. I'm going to leave 3 out. 3 is not really doing anything for me, so I'm just going to leave that outside. And what I want at the moment is I want to find the c value that would make this a perfect square trinomial. Alrighty? Now, to just reiterate that I'm doing this correctly, let's look at the graph. So if I have negative 16x squared plus 96x plus 3. This is the function that I'm looking at. It's pretty high up, so maybe I should just adjust this. Let's give you 500. No, too high. Let's do 250. Okay, good. And let's adjust this so that it's 20 by negative 20, and that's pretty good. All right, if I just factored out negative 16 from this equation, I have x squared minus 6x, sorry, and then plus 3 on the outside. Now, again, did I change anything? No. So I am already on the right track. Now I just need to figure out what c value I should use. Well, negative 6 divided by 2 is 3, and 3 squared is 9. So I want to add 9 to this equation. But if I add 9, I also have to subtract by 9. Okay? So let's go ahead and see what that looks like. Negative 16 x squared minus 6x plus 9 plus 3 minus 9. Okay, why don't I? Oh, interesting. So I'm not doing something correct here. I'm doing something wrong, because if I did my math correctly, then the green parabola should be exactly the same as the blue parabola. So let's think about this for a second. Why is it that adding and subtracting by 9 isn't working here? Well, think about it. If I just factored out a negative 16 from the terms in the parentheses, that means to get it back to the original equation, I could distribute negative 16 into the parentheses, which means I'm not really adding 9 to this expression, to this equation. What I'm really doing is I'm adding 9 times negative 16 to the expression, right? Because if I was to distribute negative 16 into the parentheses, I'm also going to multiply it by a positive 9. So to make sure that the equations are equivalent, what I have to do when I add 9 to the equation, to the function, I also have to subtract by negative 9 times negative 16, right? If I added 9 to the equation, and that 9 is being multiplied by this negative 16, then when I subtract by negative 9, I also need to multiply it by negative 16. Okay, let's see if that fixes the problem. So take 9 and multiply it by negative 16. And what do you know? It works. Good. All right. Now, that is a hard concept to understand, so I'll explain it again with a different problem, but let's just keep going for now. So now that I have my perfect square trinomial, I can factor it into t minus 3 squared. And then I'm going to combine all this that I have on the outside. Negative 9 times negative 16 is 144. 144 plus 3 is going to give me 147. So now I have this in vertex form. So that was negative 16 x minus, was it 3? Yeah, it was 3 squared, and then plus 147. And look at that. All of these guys are the same. So I have worked the system, and I've done it with correct math. So now I can find the max height of the vertex, the max height of the baseball. So the answer to this problem is that the max height of the baseball is 147 feet. All right. So first question answered. Second question, how long does the baseball take to hit the ground? Now remember, if I want to figure out how long it takes, I'm looking for the seconds, which is represented by t. And if I want to know how long it takes before it hits the ground, well, the height is represented by y. And if I'm at the ground, that means my height is y. So second question is replace y with 0. Since I'm at the ground, my height is 0. Leave it in vertex form and solve by isolating t or solving for t using square roots. So I start by subtracting 147 on both sides, dividing by negative 16 on both sides. I'm going to leave it like that. I'm not sure if it could be simplified further, but we're going to leave it. Because now when I square root both sides, I have a perfect square in the denominator that I can simplify. So 147 over 4, don't forget the plus or minus, equals t minus 3. Add 3 to both sides, you get 3 plus or minus 147 over 4. Now, again, this is a word problem. There's a context. So if somebody asks you, how long does it take before the baseball hits the ground? And you say 3 plus or minus the square root of 147 over 4, they look at you like you had 10 heads. So we're not going to leave our answer like that. We are going to simplify it using our calculators. So go to your calculator. It was 3 plus square root 147 divided by 4. So that's 6 point, you know what, Rich, let's just round to a nice whole number. No, let's be extra. 6.031. So t is approximately 6.031. And let's see what the other one is, even though I'm pretty sure that we are just going to use that value. Square root 147 divided by 4. This was the calculator that I used to use when I was in high school, by the way. And you get negative 0.031. Ooh. Again, this is a context, so only one of these answers makes sense, and it's this guy, okay? So how long does it take the ball to hit the ground? About 6 seconds. It takes the ball about 6 seconds to hit the ground. Molto bene. Okay, so that was a pretty hard problem. Let's try another problem where we have an a value that isn't 1, and we're dealing with a function as opposed to an equation. So I'm going to come back to example 4, and I'm going to say let's pretend that the original problem was y equals 3x squared plus 12x plus 15. And what I want to do is I want to complete the square. So, like I said, it's an equation, or if it was an expression, the same thing would apply. So I can't just divide everything by 3. What I have to do is I have to factor the 3 out. And I'm not going to factor it out of all 3 terms, even though 3 does go into all 3 values evenly. I'm only going to factor it out of the first 2 because even if I factor it out of all 3 terms, I don't get a perfect square trinomial. And that's my whole goal. I want a perfect square trinomial to be what's in the parentheses. So I'm only going to factor it out of the first 2 terms. So when I do that, I just get 3 times x squared plus 4x. And then I'm going to leave a space there for my perfect square. And I'm going to leave 15 outside by itself. Okay? So I'm going to leave 15 on the outside. And now I'm going to focus on getting my perfect square trinomial. So what value divided by 4 and squared do we get? We get 4. Now, if I add 4 to the equation, to the expression, I also have to subtract by 4. But do you remember what I have to do in addition to that so that I make sure my equation is equivalent to the previous equation? This 4 here is going to be multiplied by 3. So really what I'm doing when I add 4 to the equation is I'm adding 12. So if I add by 12, I also have to subtract by 12. Ooh, not negative. It should be just a positive 3. Okay. And now I can continue the process. We get y equals 3 times x plus 2 squared plus 15 minus 12 is going to be plus 3. Okay. Again, let's just confirm all this with the graph. I feel like looking at the graph gives us a nice visual of what's happening here. So if I had 3x squared plus 12x plus 15, that's the graph. If I factor out the 3, I have x squared plus 4x, and then plus 15 on the outside. Still looking good. If I add my perfect C value to the expression, and then I also subtract by it, see, it's already not the same, but if I multiply by 3, now it is, looking good. Keep going, factor that, x plus 2 squared. Combine your like terms outside, and you get 15 minus 12, 3. Very good, okay? Hopefully, seeing that problem, it helps make a little bit more sense. And you will see problems like this later on in the practice. All right, but that's it. So I hope that this made sense, and I hope you guys enjoy the rest of your day.